Hello my dear students, welcome back to the session. In the last session, we discussed one-to-one transformation from sinusoid to complex or phasor to complex also we can transform. Yes or no? Okay, we discussed that. And we also discussed volt-amp relationship, okay, between voltage and current, current lags, current leads, current is in phase. In case of all RLC elements we discussed. We also discussed that the power, instantaneous power, average power. Okay, we already discussed that. Now in this session, let us have once again, I think all of you know complex numbers. Still, I would like to just quickly, explain you what is a rectangular form or representation of any complex number. You know that very well, yes or no? Okay, so this is A is equal to A plus JB is the rectangular form. Polar form, usually you take A is equal to A at an angle of alpha, where A is the magnitude of this complex, A, complex vector or complex number A, where A is equal to A plus JB if you take root A square plus B square, and alpha is equal to tan inverse B by A. This is the rectangular form, this is polar form. In the complex plane, usually when you have a real part and imaginary part, this is the real part, this is usually imaginary part. So this is the real part, that is A, okay, this is A, and this is the imaginary part, that is B, okay, this is B, and this is nothing but, okay, root A square plus B square, okay, A square plus B square, okay. So this particular one is the magnitude of that phasor A or complex number A, complex vector A, otherwise you can say. In the same thing, you can also represent the magnitude and phase angle. This is magnitude A, okay, and this is what the alpha, angle alpha you can say. Here also the same thing, okay, same thing, but this is a rectangular form representation, this is a polar form representation. Now exponential form can also be taken as exponential form. A is equal to A at an angle of J alpha. The same thing, alpha and A. Fourth one is trigonometrical form. Trigonometrical form. Trigonometrical form. A is equal to mod A of cos alpha plus J sin alpha. Okay. So magnitude A you know very well what is that value, and alpha value you know very well. Okay. So these are all various representations, and you can also see the transformation. For example, you have a voltage something like this, V of t is equal to some 100, okay, root 2 sine some 4t plus 60 degrees. I would like to transform it to complex form or phasor form. I explained you already the table, okay. So capital V, in some textbooks they write, the maximum value at an angle of 60 directly. Some textbooks they write, this is the phasor form, we can say, phasor form. Okay, when you want RMS form, you need RMS form. Okay, you need RMS form. Generally, you write 100 root 2 by root 2 at an angle of 60 degrees. So some textbooks follow directly RMS form. Some textbooks may take even maximum. Okay, that doesn't make any difference. Wherever you want RMS, simply you take by root 2 of this particular value. That's it. Okay, and if you have any phasor value, that is, let us say V is equal to, okay, some 200, let us say 200, okay, at an angle of some minus 30 degrees. Usually the frequency information is missing here. So either he will give the frequency directly or indirectly he will give, okay. Otherwise, if I do not know, I can write generally V of t is equal to, okay, 200. If it is a phasor form means this is the maximum value. If it is an RMS form, what is this? RMS form means what? This is an RMS value. Then I need to get maximum value. RMS is equal to maximum root 2. Then maximum is equal to RMS into root 2 you will get. Yes or no? Therefore, you must be careful. Generally, phasor form is given. So there is a transformation that you can remember from sinusoid to phasor and phasor to sinusoid. Okay, so now if I take directly the phasor, the 200 sine, I do not know the frequency, therefore omega, let us say t minus 30 degrees. That's it. So this is what actually the instantaneous form or sinusoid form, and whereas this one is what complex form or phasor form. So phasor form to sinusoid and sinusoid to phasor form. So some textbook I told you, some people may take even by root 2. That means they are actually dealing with RMS value. Okay, RMS phasor, the normal phasor representation. This is an RMS phasor representation. Okay, so this is how you can take. So please take down quickly here these two examples in the complex numbers. And before that, before you note down, let me even complete the addition and subtraction, multiplication, division rules of the complex numbers. Usually for addition, subtraction, if you take a plus jb and b is equal to c plus jd, okay, c is equal to a plus or minus b, let us say, then you will get generally addition subtraction rectangular form is more comfortable, okay, to deal with. So a plus or minus c plus j b plus or minus d, this is what the final complex that you get real value and imaginary value. Okay, now here if you take a is equal to a at an angle of alpha, usually multiplication and division polar form is more comfortable. Okay, so if you have this, you can say c is equal to a into b, you can write then magnitude a and magnitude b at an angle of alpha plus beta, and d is equal to, if you have a by b, then magnitude a by magnitude b at an angle of alpha minus beta. Okay, and you can also take an example, okay, or put a note. First of all, put a note that magnitude c is not same as magnitude a plus or minus magnitude b. In fact, magnitude c is magnitude of a plus or minus b. I hope you understand this. This is very, very important. Most of the people in a hurry, in exam, they do common mistakes with this particular one. Okay, so you can proceed with this. This is one, and other one is magnitude c is equal to magnitude a into magnitude b. It is not a problem. Okay, directly you can take. Magnitude d is equal to magnitude a by magnitude b. I can take. That's not a problem. Okay, and one more example you can take here, that if you have some d is equal to some a complex plus b by c, if I deal with only magnitudes of this particular complex numbers relationship, okay, then what will I get here? Magnitude d is equal to magnitude of a plus b by magnitude c. You cannot take magnitude d is equal to magnitude a plus magnitude b by magnitude c. It is not possible. You understand? Okay, based on this particular relationship we have explained already. Okay, addition and subtraction of the complex numbers. When you deal with complex values, this is what the ultimate relationship. But when you deal with the magnitude, you are supposed to maintain this. Okay, so here also I maintained the same thing. The total magnitude of a plus b are supposed to take here. It's not like, magnitude a plus magnitude is not, it's not viable. But here for division it is viable. Yes or no? For division, what will happen here? Magnitude a by magnitude b here. Okay. So these are all simple properties. I think you have already studied in mathematics, but still I'm just giving a recap so that you do not do any mistakes in our network theory. Okay, AC circuits. Come on, do it all of you quickly. Note down. I just give you time, 2 minutes. Just quickly note down, all of you. So this is all about the complex numbers, to be remembered before we go for the actual problems, the AC circuits. And the next part is phasor diagrams. Okay, phasor diagrams also, I think all of you know, in your +2 standard itself, you might have studied parallelogram theorem. Okay, addition and subtraction of phasors. Okay, all these things I think you might be knowing. So phasor diagrams in this, generally how do we draw the phasor diagram? First of all, we need to list out all the phasors. All the phasors, for example, 10 at an angle of, let us say, some 30 degrees. Okay, B is equal to 20 at an angle of minus 45 degrees. C is equal to 30 at an angle of some 60 degrees, let us say. And D is equal to 40 at an angle of minus 90 degrees. Clear? If you take all these phasors in the phasor diagram, usually we need to take one phasor as a reference phasor. That is a common practice. But which phasor is supposed to be taken as a reference phasor? Whichever the phasor is offering angle 0, that must be taken as a reference phasor. But no phasor in these four phasors, no phasor is offering 0 angle. So what shall we do? So let us assume some fictitious phasor, 0 bar. Understand? So let us take A. What is A now? A is 10 at an angle of 30. 10 is a magnitude. 30 is an angle of A with respect to reference phasor. Getting all of you? So what is A? A is a 10. Usually the magnitude is written at the tip of the phasor. The angle is shown like this, and you generally have a positive angle. When you have a positive angle, you move from this reference phasor in counterclockwise direction. So this is 30 degrees. Getting all of you? Okay. Well, B is equal to 20 at an angle of minus 45. So negative angle, usually you must move from this reference phasor in clockwise direction. And the magnitude is what? How much it is? 20 and minus 45. Magnitude almost double to this. And this is 45. Let us say this is 30. This is 45. This is 60. Assume that. Therefore, you get. So this is what? B at an angle of. B at an angle of what is this? 45 degrees. Now C is equal to 30 at an angle of 60. 30 at an angle of 60, you take now 60 degrees, again positive angle. So 30 and 45 and 60 somewhere, something like this. So this is what C. C at the tip of phasor magnitude, and this is going to be 60 degrees. Okay, this is going to be 60 degrees. 60 degrees. Okay. Now D minus 90 degrees. D minus 90 degrees. So what will happen here? This is going to be 90 degrees. Magnitude D you can take. Okay. So this is how generally you represent the phasor diagram. Okay. All the phasors on the phasor diagram. Once you know the magnitude and phase angle, you can represent like this. It's a basic concept I think everybody knows, right? Now coming to, there are two phasors. Let us say A is equal to A at an angle of alpha. B is equal to B at an angle of beta. Now the angle alpha in case greater than beta, okay, then you can say A leads B by how much? Alpha minus beta. If at all alpha is less than beta, then you can say A lags behind B by beta minus alpha, because beta is greater. Yes or no? Beta minus alpha. If alpha is equal to beta, then A is in phase with, yes or no, all of you, we already learnt it. Okay. Now, in case if angle phi is alpha minus beta and alpha is greater than beta, okay, with these conditions, can we draw the phasor diagram? Yes, we can. Take one reference phasor. Take one reference phasor. What is the reference phasor actually here? Some 0 bar. Assume that alpha is positive, beta is positive, but alpha is greater than beta. And angle phi is the phase difference between alpha and beta. And you can also take C is equal to A plus B. Okay. I would like to go with C, phasor C. Now A or B you can take. This is A, let us say. This is A. And this is B. Okay. This is B magnitude. And this is A magnitude. This is alpha. Sorry, this is alpha. Okay. This is beta. And this is what alpha minus beta. So according to parallelogram theorem, you can say, okay, this is A, again this is B, the same B I'm adding here, the same A I'm adding here. At the tip of B, if you add A plus B will give you what? C. Therefore, the result is something like this. The result is something like this. So what is this now? This is C. Okay, the magnitude of C will be, okay, here written on the tip of the phasor. So how much angle that C is made? The angle of C, let us say it is theta. Let us assume that. So this is making an angle theta. You understand? This is making an angle theta. Now from this, look at this, all of you. From this, if you, I think all of you might be knowing some of the horizontal components, some of the vertical components. The resulting phasor C, its horizontal component value is equal to sum of the horizontal components of A and B. Yes or no? Because A is equal to, C is equal to A plus B, then obviously you can split this phasor into two parts. One is the horizontal component, the other is the vertical component. Any phasor can be divided. Yes or no? I think you learned that already in your mathematics or at +2 level itself. So what is that actually? You have C cos theta is equal to A cos alpha plus B cos beta. This is equation 1. C sin theta is equal to A sin alpha plus B sin beta. Okay, equation 2. Now equation 1 square plus equation 2. Okay, equation 1 square plus equation 2. Then what do you get here? C square is equal to A square plus B square plus 2 AB cos alpha minus beta. But what did you call this alpha minus beta? Is a phi. Yes or no? So I can say cos phi C square minus A square minus B square by 2 times magnitude A and magnitude B is very, very important here. This is very, very important relationship. Understand all of you, okay? And equation 2 by, because my intention is to find the magnitude of C and the angle of C. What is it I'm trying to find here? The magnitude of C and angle of C. At the same time, if I know magnitudes of this C, A, B, can I find the phase difference between A and B? Yes, I can do. If I know all these values, then I can find C. If I know all magnitudes, I can find the phase difference between A and B. I can also find the angle of C. What is that angle of C? Angle of C. Tan theta, yes or no? Because sin theta by cos theta, you will get sum of vertical components. A sin alpha plus B sin beta by, okay, what do you get? A cos alpha plus B cos beta. Then you can get theta is equal to tan inverse of, you can get all these values. Yes or no? So all these you can put here and you get the value of theta. I hope you understand. Theta is equal to tan inverse of what? Sum of all vertical components by sum of all horizontal components. You can remember that. You need not to by heart all these formulas. You can easily, recollect the formulas if you know the concept here. Understand all of you, okay? So please note down all these things quickly and we'll move on to some other case here, case 3. First you please note it down. You must be good at drawing the phasor diagrams. It's very easy concept if you know that parallelogram theorem and phasors, addition and all those things. It's not a big deal. You can easily draw the phasor diagrams. So the same phasors I would like to take with a slight modification in this case 3. I'm just trying to take case 3 here. Say A is equal to A at an angle of 0, let us say, and B is equal to B at an angle of phi, let us assume that, and C is equal to C at an angle of theta. Understand? Okay. Now once again C is equal to A plus B. The same thing I'm trying to do, whatever I did in the previous case. I also did the same thing here, yes or no? C is equal to C at an angle of theta. and C is equal to A plus B, I did, right? The same thing I would like to do, but with a different angle. So what will happen here? Now this phasor is taken as, okay, this is A, magnitude, usually magnitude, okay. Now, then what B, angle phi, let us assume that it's a positive value. Then what do you get here? B is this phasor, okay, this is what B actually. But the same B, I can draw at the tip of A so that the C can be written here, okay. So I just draw now at the tip of B. Usually this is a good practice to draw the phasor diagram, but what is my objective here? I want to get A plus B, nothing but C. So what I do is, first I have drawn A, and at the tip of B, at the tip of A, I would like to draw B. So what is that? B actually is making an angle. This is B making how much angle here? Some phi, okay. Now if you add these two from this O, let us say this is O is the origin, let us say. Now this is going to be, okay, this is going to be C. This was B and this is C now. Understand? Okay. So I can say the magnitude, the length of this phasor is OA, the length of this phasor is AB, the length of this phasor is, let us say, OC. If I take O, I can also talk like that. Or as the magnitude of this phasor is mod A, magnitude of this phasor is mod B, the magnitude of this phasor is mod C. Like that also I can take. Okay. Understand all of you? Okay. Now what will happen here? You take, now this is theta. This is theta. Now the same thing I can take here. What is that? Actually cos phi. Cos phi is C square minus A square minus B square by 2AB. The same formula, it does not change. Yes or no? And C can also be determined if you know the angle phi. And same time, theta will become tan inverse. Here phi is equal to cos inverse, theta is equal to tan inverse. Yes or no? So what do you get? Sum of vertical components by sum of horizontal components. So what is the vertical component of this particular phasor? There is no vertical component because it's making an angle 0. So sine 0 is 0. Only horizontal component, there is no vertical component. But B sine, what is this? B sine phi by, what is that you have? A, horizontal component, A only, that's it. Okay, so B sine phi and A plus B cos phi. That's it. So theta is equal to, this is what now, cos phi and then theta. That's it, you're going to get. Okay. So this is how you, the same thing I've done here, but earlier I've taken alpha, here beta, but now I'm taking this 0. Now A is taken as a reference phasor. Okay. So note down this. Note down this. Meanwhile, I just remove this particular part. Quickly note down that part. I explain you some other important concept. Note down. You can also write the same thing as cos phi is equal to OC square minus OA square minus AB square, yes or no? Okay, divided by 2 magnitude of OA, magnitude of what? AB, yes or no? Like this. Similarly, theta can be written as tan inverse of, okay, AB sin phi by, what do you get? OA plus AB cos phi. Both are same. Yes or no, all of you? Okay. Both are same. The length of the phasor, I'm taking OA. This is OC. This is AB. Like that I can proceed. The fourth important concept. I think you have written that, all of you. Now look at this. Don't write anything. I'll give you time. But look at this concept. I think you have written this part. Please note down this also. The fourth one is very, very important here. Very, very important here. Very, very important here. Look at this. Suppose if I draw the phasor diagram like this, the same thing, C is equal to A plus B, OA, AB, OC. Look at this. Let magnitude of OA is equal to magnitude of AB. Understand all of you, okay? If magnitude of OA is equal to magnitude of AB, if magnitude of OA is equal to magnitude of AB, what could be the angle theta and phi relationship? You understand? Okay. The theta and phi relationship will become theta is equal to phi by 2. That means it is exactly bisecting the angle. The angle difference between A and B. What is the angle difference between A and B actually here? This is B, right? This is B, right? So this is phi, right? Yes or no? The same phasor I am drawing here. The same phasor I am drawing here. This is B, let us say. Phi. Now this is theta. Now if you have OA is equal to AB, then this theta is going to bisect the angle phi. That means I'm just giving the conditions here. If, then theta is equal to phi by 2. I hope you understand the point. Okay. Now another important assumption I'm taking here. Let me take this particular one. First let me draw this phasor diagram with this particular condition. So what will I get here? This is OA. This is AB, the same length I'm taking here, approximately. What is the angle here? Phi. Whatever this C, okay. Let me take them to this point. This is C, this is B, okay. This is B and this is C. Now angle of C is what actually theta. OA is equal to AB, then angle theta will become what? Phi by 2. Understand? Okay. Now if I select, if I select a point D on OC such a way that OD is equal to DC is equal to OC by 2. I hope you understand the point. That means I'm taking a middle point on OC. So what will happen? Let us see. If I take a middle point on OC, that is capital D here, definitely the angle of this D, that is ODA, will become what? Definitely it is going to be what? 90 degrees. Agree all of you? So what are the conditions? Actually, two conditions are supposed to be satisfied. Okay? Two conditions are supposed to be satisfied. What are they? OA is equal to AB and OD is equal to DC is equal to OC by 2. Then angle of ODA will become 90 degrees. You understand all of you? So from this we can say tan theta is equal to, from this we can say tan theta is equal to, I can say AD magnitude by, what is this? OD. Agree all of you? But you already know that theta is equal to tan inverse of OD is nothing but what? OD is nothing but DC, same as OC by 2. Therefore, AD by OC by 2. Agree all of you? But what is theta? Theta is nothing but phi by 2. So tan inverse 2 times AD by OC. Now finally you got from this, okay, phi, angle phi is equal to tan inverse 2 times AD by OC. Okay, exactly on this particular formula. There was one question given in the gate. Understand all of you? Okay, it is purely based on the phasor diagrams concept. So you need to remember only two phasor diagrams, very important. One is that A plus B, that is nothing but C, you are getting this particular formula. This is also useful to you when you find choke coil parameters R and L values. This phasor diagram is going to help a lot. Secondly, this is very important even the exam point of view. Directly there was one question on this particular phasor diagram. There was one circuit given and he designed a circuit in such a way that you need to draw this particular phasor diagram and try to answer the question. That formula was the final answer. Okay, so please note down this part, all of you, quickly. Note down. Meanwhile, I just remove this part. Okay, I think you have noted down this, right? Quickly note down. Hope you have noted on this part. Okay, quickly complete that part. What are the two conditions that you are taking? The two important conditions. First condition is what? What is the first condition? OA must be equal to AB. Okay, then theta will become what? 5 by 2. If OA is equal to AB and OD is equal to DC is equal to OC by 2, then angle ODA will become what? 90 degrees. So if I know that is angle 90 degrees, here D is making an angle 90, that is AD is making an angle with respect to OD, then I understand tan theta is equal to AD by OD. That's it. From this I can derive this simple formula. Please note down that, all of you. OA, AB, OC, then middle point I have selected. So hope you have finished that. So these are the minimum basics one should really know on complex numbers and the phasor diagrams, okay, before you proceed with the AC circuits. People who do not know these things, they face a lot of problem in analyzing the AC circuits. Okay, they can solve only particular problems. They cannot do all problems. Okay, so that is why I again tell you that be perfect on all these fundamentals. Okay, now coming to the definitions here, I think all of you know what is a resistance. There is no need to define it. R is a resistance, you know very well, ohmic value. G is a conductance, which is the reciprocal of resistance. No doubt, Siemens or Mohs. Okay. Then third one is reactance. XL is reactance, inductive reactance. Inductive reactance. As a circuit element, when you analyze AC circuits, okay, people represent sometimes in time domain. This is L. And in complex domain or phasor domain, because you need to convert all the time domain circuits into complex domain or phasor domain. In such case, usually, okay, we take JXL. So how we got this JXL? Why we are representing it JXL? It is because of this mathematical, because sometimes people may ask you in the interview, how you got this J term? You can take this, explanation. This is V of t, let us say. This is I of t, let us say. What is the relation between V and I? V is equal to, okay, L d I by dt. Yes or no, all of you? If you go for transformation, what is the transformation? Time domain to complex or phasor? We already drawn a table, yes, all of you, in the previous session, yes or no? So with that, what you do is V is equal to, capital V is equal to L into the di by dt can be written as what? J omega capital I. Yes or no? So I can write it as what? J omega L into capital I. But what is J omega L? Nothing but JXL into capital I. Yes or no, all of you? So V is equal to JXL into I. It's a Ohm's law. Capital V. In complex domain, the Ohm's law says that V is equal to capital I into JXL. So to maintain that relation mathematically, we need to represent this L in the complex domain or phasor domain as JXL only. Understand all of you, okay? So time domain L and complex domain or phasor domain, it is JXL. Understand all of you, okay? Third, then fourth one is you have BL, inductive susceptance. Inductive susceptance. What is inductive susceptance? The reciprocal of inductive reactance is nothing but inductive susceptance. Okay? It's nothing but 1 by omega L. Nothing but 1 by 2 pi FL. Nothing but capital T by 2 pi L. Okay? Now, as a circuit element, when you take L, okay, in time domain, but whereas in complex domain, you know that it is 1 by L, right? 1 by XL, sorry, 1 by XL. So 1 by JXL. So 1 by JXL means 1 by J is nothing but minus J. 1 by XL is nothing but BL. So as a circuit element, generally in complex domain, you take it as minus JBL. Understand all of you, okay? So fifth one is capacitive reactance. Capacitive reactance. In time domain, it is C. In complex domain or else phasor domain, you take minus JXC. So how you got minus JXC? Let us discuss here. What is this V? What is this here? I. V is equal to 1 by C integral I dt. Now use the transformation. One-to-one transformation, you know very well, transformation between phasor to sinusoid or sinusoid to phasor. So capital V is equal to, what do you get? 1 by, okay, C. This is nothing but what? 1 by j omega into capital I. So you know that 1 by j omega C minus j, 1 by omega C is nothing but what? XC into what? I. So you got clearly that V is equal to I into, what is that? Minus JXC. So with that you are getting that, you know, minus JXC. Clear all of you? Because sometimes in interview you may be getting questions, simple questions, whether you are simply remembering that minus JXC, okay, or minus JBL or plus JXL, or else you know how they got, okay, how they arrived, okay. So you must be knowing all these things, simple things, but you must be knowing how we derive it. So that table is very, very important. Sixth one, BC, capacitive susceptance. Capacitive susceptance. What is capacitive susceptance? In capacitive susceptance, again, this is C in time domain, 1 by minus JXC, reciprocal, yes or no? So BC is what actually here? 1 by XC. So reciprocal of capacitive reactance is nothing but capacitive susceptance. So therefore you get plus JBC. Understand all of you, okay? Seventh one. Z is an impedance. Impedance. How do you define impedance? Impedance is always defined as RMS voltage phasor by RMS current phasor. RMS voltage by RMS current ratio is nothing but Z. If you assume that V is equal to V at an angle of alpha and I is equal to I at an angle of beta, then V by I at an angle of alpha minus beta. You can take it as Z at an angle of theta. What is theta actually here? Alpha minus theta is alpha minus beta. Understand all of you, okay? Theta is nothing but what? Alpha minus beta. This is nothing but theta. Getting? Now if alpha is greater than beta, it is an inductive one, right? Yes or no? Because alpha greater than beta is nothing but what actually here? You have voltage leads current, nothing but current lags voltage. Then if current lags behind the voltage, you call it inductive, yes or no? So inductive, the circuit nature is inductive because the angle theta will become positive. Understand all of you, okay? And finally you get Z is nothing but R plus J XL form. Understand all of you, okay? Because when theta is positive, what is the rectangular form of this Z? Because it is complex value, then it is A plus JB form. And in complex, you take now, it is always, because the real and imaginary, because it is A plus JB form, always it is in first quadrant. This is XL, this is R, and this is going to be Z. Yes or no? Okay. And this is going to be theta. So the triangle is upward, okay, for inductive. Whereas for capacitive, you can see here now alpha less than beta, it is now capacitive. Yes or no? Theta is negative. Theta is negative. And you get Z is equal to R minus JXC. So where do you get? This is R and this is XC. This is R, this is XC, because minus JXC. Therefore negative imaginary part. Therefore this is going to be Z. So this is going to be theta. So this is what Z actually. Understand all of you, okay? So for capacitive, you get a downward triangle. Upward triangle, downward triangle. If the triangle is upward, that means it is in the first quadrant, okay, or A plus JB form. If the triangle is downward, it is A minus JB form. That means it is in the fourth quadrant, okay? Then if alpha is equal to beta, then it is going to be what? Resistive, and theta becomes 0 and Z becomes simply capital R. That's it. Yes or no, all of you, okay? So like this you can proceed. And you also know that the horizontal component of this Z will become R. The vertical component of Z is nothing but what? XL. So I can write here R is equal to, okay, real part of Z. No doubt. I can also say Z cos theta. XL is nothing but imaginary part of Z, but imaginary part is nothing but Z sin theta. Understand all of you? Like that I can also write here XC is nothing but Z sin theta, R is nothing but Z cos theta. Horizontal component of Z is nothing but R, vertical component of Z is nothing but XL. So please note down all these things, all of you, quickly. Then we can discuss another important one, admittance. Similarly, we can proceed with the admittance, okay? Impedance we have seen, and then we can see admittance also. If you see admittance, eighth one, capital Y, generally we denote it. Admittance. Admittance is usually the reciprocal of impedance. Okay, so therefore is equal to what? Capital I by V. Capital I by V. And then we can get capital I by V at an angle of beta minus alpha. Say this capital Y at an angle of theta. Say now this beta minus alpha is theta. Earlier we have taken alpha minus beta is theta. Yes or no? This we had taken theta, but now let us take beta minus alpha as theta. If alpha is greater than beta, still it is inductive. No doubt, because voltage leads current or current lags voltage. Inductive. But now theta becomes negative or positive. Negative because beta minus alpha, but alpha is greater. Therefore, when angle is negative, that y becomes no doubt inductive, but it is A minus JB form or A plus JB form? A minus JB form, but inductive, therefore BL. Now, do you get that triangle upward or downward? Because it is negative, fourth quadrant, it could be just like that. Therefore, what could be the triangle? Downward. Yes or no? This is BL, this is G, this is Y, and this is theta. Yes or no? Now you can say this G is nothing but what? Horizontal component of Z, Y cos theta. BL is nothing but Y sin theta. Okay? For any complex value you can say here. Or else G is nothing but real part of Y. Yes or no, all of you, okay? G is nothing but what? Real part of Y. Real part of Y, whereas B is nothing but imaginary part of Y. Clear all of you, okay? Now, let us take if alpha is less than beta, it becomes capacitive. Theta will be definitely positive in this case, and then y becomes g plus jbc. Understand? Okay. So the triangle could be now what? Upward or downward? Upward, because of plus. In first quadrant, the point g plus jbc will be in the first quadrant. Yes or no? This is theta. If alpha is equal to beta, then it becomes resistive. Then theta will be 0. Then y is equal to only g. Understand? Okay, like this. Now it's very easy to understand from these two. We can generalize. If z is equal to r plus or minus jx, y is equal to g minus r plus jb. Here positive is for what? Inductive. Negative is for capacitive. Whereas here positive is for inductive, negative is for inductive. Okay. Positive is for capacitive. Yes or no? It's very, very important observation. Okay. So please note down. Note down. Students, okay, I think you might have noted down, and I'm going to stop the session here. In the next session, we'll discuss very important, that is active power, reactive power, apparent power, and power factor. Then after, we will switch on to or move on to the problems. Okay. So I stop the session here.